On November 14, 1963, the cook aboard an Icelandic trawler called the Ísleifur II looked out at the North Atlantic and saw a massive, dark column of smoke rising from the water. The crew turned their ship to investigate what they assumed was another vessel on fire. Instead, they found an active submarine volcano physically breaching the surface of the sea, violently ejecting ash and rock into the air. This eruption was happening roughly 32 kilometers off the southern coast of Iceland, right in the middle of an active underwater geological rift known as the Vestmanna submarine volcanic system. Undersea eruptions are relatively common, but the ocean usually wins. As loose ash and pumice pile up above the waterline, the relentless energy of ocean waves typically tears the new formations apart before they can solidify. But this formation kept growing. Over the next 3.5 years, it built itself into an island. It offered scientists something they rarely find, a completely sterile, brand new piece of the planet, rising straight out of the void. In its first few months, Surtsey was incredibly vulnerable. The early explosive eruptions had built a towering cone made entirely out of loose volcanic rock, known as scoria, and fine ash. We know exactly how fragile this structure was, because the same volcanic event created two other small nearby islands, Sirtlingur and Jolnir. Both were rapidly washed back into the ocean by the winter surf, leaving nothing behind but submerged plateaus. Surtsey survived because its eruption style changed. By April 1964, the island had grown large enough to block seawater from entering the main vent. Without that cold water causing explosive reactions, the volcano transitioned to an effusive phase, pouring out steady streams of liquid lava. This molten rock flowed out over slopes of loose ash, right down to the shoreline. As it met the cold ocean water, it rapidly cooled and hardened into a dense, solid rock barrier. This outer shell armored the island against the Atlantic waves. By the time the eruption finally stopped in 1967, that geological transition from explosive ash to effusive lava had physically guaranteed Surtsey's survival. With the island stabilized, the Icelandic government recognized a unique opportunity. In 1965, they declared Surtsey a highly restricted nature reserve. Only a handful of scientists were allowed to visit, keeping the environment free from human interference. They wanted to study primary succession, the step-by-step biological process where a completely dead environment is colonized by living organisms. Plants were the first to settle. Within a few years, seeds from coastal plants like the sea rocket drifted across the ocean currents, washing ashore and managing to take root in the nutrient-poor volcanic sand. Then came the seabirds. Species like the black guillemot began landing and eventually nesting on the rock. Their arrival was critical because their droppings, or guano, provided the nitrogen and phosphorus needed to build actual soil out of sterile ash. Together, the currents and the birds transformed the island. Surtsey showed researchers in real time how life builds a complex ecosystem from scratch, relying on a highly specific sequence of external deliveries. But in 1969, researchers found something that did not fit the sequence. Growing out of the dark volcanic rock was a small, fully formed tomato plant. Tomatoes obviously do not float across the North Atlantic, nor are they carried by seabirds. An investigation revealed the actual source. A visiting scientist had eaten a tomato, improperly handled his own waste on the island, and the undigested seeds had taken root. To protect the integrity of the long-term experiment, the researchers had to immediately uproot and destroy the plant, carefully removing the contaminated soil. The incident was quickly resolved, but it highlighted exactly how aggressive life can be when given even the smallest foothold, and why keeping this outdoor laboratory totally quarantined requires absolute discipline. Today, Surtsey is noticeably quieter. The volcanic eruptions permanently stopped in June 1967. Since then, the ocean has spent every winter tearing at the shoreline. This topographic map shows exactly how much land has been lost. In 1967, the island covered 2.65 square kilometers. Today, it has eroded to 1.4. The most severe damage is on the western edge, where heavy winter surf has steadily sheared away the exposed cliffs. The erosion rate is actually slowing down. Over decades, the internal heat from the volcano chemically altered the loose ash deep inside the island, compressing it into a highly resistant rock called palagonite tuff. That hardened core is tough enough to withstand the ocean for centuries. Surtsey will eventually return to the sea, but while it stands, it serves two unique purposes. It gives geologists a step-by-step record of how the Earth physically constructs land, and it gives biologists an untainted look at how